Here is an exponential expression written as power of power. Power of power means like this. Let's say 5 to the power of 3 to the power of 2. Okay. So we have exponent and then another exponent over it. So power of power. Now here, what does this inside term in the bracket means? Let me write that. 5 to the power of 3 means 5 times 5 times 5 and then to the power of 2. Correct? Yes. Now, what does this means? This means that I have to multiply this factor 2 times, right? So this means this. 5 times 5 times 5 times 5 times 5 times 5. So how many 5s are being multiplied, or how many factors of 5 are here? 1, 2, 3, 4, 5, 6. So we get 5 to the power of 6 in our exponent form. Correct? So here we saw that when we have power of power, then the result is 6, which is 3 times 2. Is it always true? Let's try. Let's try with a general number, and let's say my general number is a to the power of 4 to the power of 3. There are too many a's now. Okay, so a to the power of 4 means that I have a, 4 a's, and this is to the power of 3. Now, this to the power of 3 means I'll have to write this factor 3 times, correct? So how many a's will I have? 4 times 3, 12. Well, let me write also. So 1, 2, 3, 4. This is first factor. We have to do it 3 times, right? 1, 2, 3, 4. And one more. 1, 2, 3, 4. How many a's do you see here? Well, 4 plus 4, 8 plus 4, 12. How do you get 12? You get 4 times 3, 12. So I could write this as a to the power of 12. So in general, power of power gives us something like this. If I have a to the power of m to the power of n, what should this be equal to? This should be equal to a to the power of m times n. Okay? This is what we are getting all the time. Right? So this is a law of exponents, that if we have power of power, then the powers get multiplied. Base remains same. Correct? So remember this law and you can try to solve some questions. For example, I'll combine product and power together and give you one. For example, if I write a square b cube to the power of 4, it means what? This is not just a power of power, it is product with power of power. Product of two terms. Do you see a and b, two different variables? Now using this property, it means that a square b cube, 4 should be multiplied with this and also with this. Okay, let me show you in a different way. So this means that we have here 2 a's, right, and 3 b's multiplied together and to the power of 4. Correct? Now that means I'll have 4 such factors, just as I had with a's. So if I have 4 such factors, how many a's will I have? Here I have 2 times 4, which gives me 8. So I could write this as a to the power of 8 times b to the power of 3 times 4, 12. So using power of power, we could simplify this as this. Correct? So this property is actually product of power, okay? We could use it in the quotient form also. For example, I could write like this: a to the power of 3 over b to the power of 2 to the power of 3. In this case, how will this expand? This will expand as 3 to the power of 3 is 9, so a to the power of 9 over b to the power of 3 times 2, 6. Okay? This is also power of power, but with quotient underneath, right? So we have applied this power of power in this case for a quotient, and in this case for a product. And this is a simple power to power property, power of power, okay? But basically it's the same thing. We are multiplying the exponents. You remember when we were multiplying earlier two exponents? In that case, we added the exponents. But when we have power of power, we multiply them, okay? So multiplying powers with the same base results into addition of exponents. And power of power results into multiplication of exponents. Correct? So try to remember that, and then we'll move forward to zero exponent and negative exponents. Okay, thank you.